We'll just get started in a while, okay? I'm waiting for the others to join. Let's see. Hope others will join the session. We'll wait for a couple of minutes, okay? Yes, you're audible. Yeah, I'm audible. Can you hear me? Right. We'll wait for a while. So, just only two of you. Okay, fine. Maybe we'll get started. It's already 6:05. Um, can someone confirm that I'm audible? There are only two participants today. Either of you, can you just confirm that I'm audible? Okay, thanks for the response. Okay, now for the people, were you there in the previous session, or this is the first session both of you are attending? This is your first session. The other person, Mr. Tovaraju, is this your first session, or this is your first session? Is it? Okay. Okay, Mr. Harsha. Oh, sorry, Harsha Preeti. Okay. Is this your first session, or you have attended previously? Okay. Yes. See, for the people who have come new, I'm Chaitanya. I'm a PhD candidate at IIT Madras from Department of Chemical Engineering. Okay, so I'll be taking these tutorial sessions for this semester. Okay. So how these tutorial sessions are planned is, I'll just briefly summarize the weekly lectures, whatever professor discussed in the class, and then we'll try to have some tutorial problems where if you have Aspen with you, I'll just give you a problem asking you to solve, and then respond if you're having any difficulties in between. I'll try to answer your queries, etc. So and so. And then I have few question and answers. Okay, so these question and answers are made such that this proves that you are able to follow the lectures and all. Okay. However, for just proceeding further, can you confirm if you have Aspen now and you can use it during this session? Can you just put it in the chat box if you have Aspen now? How many of you have Aspen? You are about four students have joined to the session. Among four, how many of you have Aspen with you now? You have. Okay, thank you. Others? Okay, you have. Thank you. Two of you have others too. Other, what about the others? So you have, right? All of you. There's one more candidate, Nirish. Okay. See, thing is, I am outside institute. Okay, so as of now, I don't have license to Aspen, so I won't be able to show you the solution procedure in case if you are stuck somewhere. However, if you are just having doubt anywhere, I know whenever I go back to institute, I can just put a recording of that on the portal. Okay, that way I can do. However, today I don't have a license to Aspen. Okay, for the next 2 weeks, I'm on leave, so I will be outside institute. So for that reason, I don't have this Aspen connection. Okay? Although I have software, but I don't get license. Okay, so I won't be able to show you the solution as of today. Let's try it out. Okay, let's see how this works. If you have any doubts, I can just record your doubts in future whenever I go back to institute and then show you. So that way I'll be able to manage. However, for today, I don't have license. Fine. So, this week professor started discussing about different gates on the model pellets available in Aspen, which were not explained in the previous session. So he started with reactors. So he explained three categories of reactors, which are based on stoichiometry, equilibrium, and then kinetics. And then individually, he tried explaining what is the specialty of that model pellet, what does it do, and all. Starting from stoichiometric based reactor, and then yield based reactor, then equilibrium based reactor, and then Gibbs based reactor. So he took one of the example of water gas shift reaction for explaining these things. And further, he just discussed about sensitivity analysis little bit. We'll also do a lot of sensitivity analysis in future, sensitivity analysis and optimization, design spec calculator, etc., etc. Okay. Yeah, surely not for this week and the coming week because I myself don't have access to Aspen, so I won't be able to show you the examples. After that, we'll be doing it. Okay. And then further, he took example of pressure changes, which are pumps, turbines. So he explained what is this characteristic curve, efficiency curve, and then we talk a little bit about the turbines. Okay. So yes, there were a few problems which were solved. Then the flow sheet construction, right? So till the lectures, were they clear to you, or you have any queries with the lectures of this week? If you have any doubts, now you can just put it in the chat box. Okay, with respect to this week lectures, whatever you had issues with the lectures, that we can discuss, or else I have few questions for you. See, today lecture is going to be a bit short since I don't have this Aspen license as well as I'm on leave. So I have many personal engagements over here. So today's lecture is going to be short. However, if you have any queries, I'll take a note of them. I'll try to respond at the earliest possible. Okay. So just let me know if you have any questions related to the week lectures. Any one of you, do you have? Yeah, what is your doubt? You can just unmute and talk. So, sorry, I couldn't get your question. I couldn't get your question. Can you just repeat it? You want to change VL model to VLLE. Is that your question? Hmm. Liquid mode. Okay. Then this need to have. Yeah, yeah, I can hear you. So I'm just thinking, how can I tell this oral? I need to show you how do we change it in Aspen. That's what I'm thinking. I see. It's difficult to answer this question orally. Okay, I'll do one thing. Uh, I took a note of your question. Okay, I'll ask my friend to give me a TeamViewer thing and just record my screen and then upload this. Okay, it's difficult to show. I mean, tell this orally. If you have something which I can explain orally, that'd be really great. Do you have any such? However, I know I got your question. I just took a note of it. Okay, give me some time. I'll answer this. See, I don't have Aspen licenses. No, I'll try doing it by tonight. Okay. I understand that. I got your point. I'll try doing it by today. Because see, I'm outside institute, okay? I'm on academic leave, so it's difficult to get the license as of now. I'll try answering your question by tonight, okay? I'll just record it and upload it in the drive link, whichever I have shared previously. Yeah. Any other question do you have? If I can able, I mean, if it is possible to answer orally, do you have any such? Okay. See, in your Swayam portal, there is a tab called Problem Solving Session. Okay. In that, if you go, there is an Excel spreadsheet which is shared. So that Excel spreadsheet has the link in which I'm share. That's a folder link in which I share all the discussion files, whatever we have used in these sessions. Okay. There I'll write and there I'll upload. Okay. Even this session is getting recorded, so that will also be shared to you. Okay, so I have a few questions for you. Okay, so these questions are made such that if you are able to answer these questions, that gives me a confirmation that you are able to follow the lectures and all. So can you just answer the reactor simulation may be performed using which among the four options given over here? I just put it in the chat box. Okay, whatever you feel the answer. Can you answer this question? Which among the model pellets given here is used for reactor simulation? Can you just put it in chat box, so that others can also follow? No, I want to see how many of you are able to answer, so that's why I want to take a count. Okay, thank you. So three of you have responded. Others three, okay, thanks for the responses. Right, what is the purpose of RADFRAC? Can you tell me where we are using RADFRAC for? Which kind of simulations are we using RADFRAC? Anyone? For vigorous simulation. Okay, what is this? What do you mean by vigorous simulation? I'm asking, is it for heat exchanging purpose, or cooling heat pump kind of purpose, or extraction process? What kind of process do we use right for this? He says two of your friends says simulation of distillation falling. Okay, so can I use rate frac for multi-component separation? What do you mean by single? S- Single column absorption. Okay. So you're telling red flag can be used for distillation, right? So I have azeotropic mixture. Okay, let's say ethanol and water. Can I use red flag for the separation? Can I do that? Yes. Okay. So you mean one column will be sufficient for me to separate ethanol and water, right? Mr. Lokesh, that's what you mean? Mr. Lokesh, what do you say? Okay. So separating ethanol and water. So if you want to separate ethanol and water, one side you'll get pure component. However, other side you'll have azeotrope. Okay. So with one column you won't be able to separate ethanol and water. Okay. You need one more column for breaking this azeotrope. Okay. So yes, let me just give you another example. Uh, mm, so can I separate methanol and water which don't form azeotrope using this? Using radfrac, can you separate methanol and water? They don't form azeotrope. It's kind of a binary system which don't form azeotrope. Can I separate this using a radfrac model pellet available? Anyone? Any responses? Are you following the question, or you couldn't get it? Couldn't get it. Okay. See, I am asking a question. The first question which I asked you is, for what purpose red frac is used? So the answer what I got is for distillation. Now I'm asking, we have a binary mixture of methanol and water. Okay, can I separate these two using red frac? Separate it into pure components. Okay, is it possible? Okay, what do we do in distillation? What is distillation? Can anyone just unmute and explain what is distillation and where is it used? Yes, yeah, right. So separation of components based on the thermal properties essentially. So it's like heating and then having equilibrium of vapor and liquid. Right? It's kind of based on a temperature, thermal based separation. Correct, using thermal energy, right? So essentially you'll have a light key on the top and heavy key product on at the bottom of the column, right? So now in the system of methanol and water, which will become our light key, the component which has more volatility or a lower boiling point, right? So most likely, if right, it's methanol, right? Yeah, it's methanol, right? So methanol will become the light key and water will become the heavy key product of the column. So if you want to separate this binary system using red flag, you'll get methanol on the top and water at the bottom. However, in case of ethanol and water system, they form azeotrope. Okay. So can anyone explain what is azeotrope? What is azeotrope? Closed range boiling mixture. Okay. Adding third component. Okay, let me just show you TXY plot. Uh, water TXY plot. See, are you able to see the screen? Normally, if you have two components which don't form a azeotrope, you'll have a closed thing. Okay, this the lower curve will directly go to the other side, and the upper curve will directly go to the other side. Okay. However, let me show that one also. TXY plot. Azeotrope TXY. Okay, so normally the TXY plot will be this way. Okay, so this is the bubble point, this is the dew point, this is drawn at constant pressure. Okay, however, when you see ethanol water system, let me finish off this. So in case of methanol and water, the first case which we have seen, you will be able to see that on one side you'll have water and other side you have a methanol. Okay, so it's like the separation will become easy because one end will have water and other end will have methanol. However, when in the case of ethanol and water, there is a formation of a zerotrope. Okay, so in this case, one of if you are operating column in this region, one of the product will be the top one, which is over here. The other side you'll have azeotrope. Okay, it won't be pure ethanol. So you need to have another column to separate these two. So if you have an azeotrope, you need to have at least two columns, okay, for separation. So one column operating between 0% of ethanol to 95% of ethanol, and from 95% to 100% of ethanol is the second column. So you need at least two columns to operate. And similarly, if you have multi components, let's say instead of only two components, I'll take simple example of air. Okay, let us concentrate on the major components of air, which are nitrogen, oxygen and argon. Okay, if you take these three components, can we separate these three components into individual streams using red frag? Can we do that? Can I separate oxygen, nitrogen and argon using one column of red frag? Okay, why do you think you can't separate? Just unmute and talk. I think I'm getting very few responses in this class. See, if you don't respond, the essence of interactive session is lost. Okay, so it will just become a recording session for you again. Just try interacting. Can you just unmute and talk whatever you want? Yes, so you are correct. Through using rat flag, we can only separate two components. Okay, so in case if you want to do distillation for multiple components, then you need multiple columns. Okay, so one column can only separate two components. So if you have three components, you need one more column. Okay? If you have four components, you need one more column. And this is only the case where the given components won't exhibit azeotrope. In case if you have azeotrope based on homogeneous azeotrope or heterogeneous azeotrope, you'll have a different configuration. That is, that and all are taught in the sequencing of distillation column. That's a different course in the total. However, you need to have an idea the given component whether it forms a zerotrope or no. In one of the exercises, we'll see how do we find whether the given components form a zerotrope and all in future sessions. Okay, so let me just go ahead. So what do we use, what is the purpose of flash 3? What is it used for, the flash 3 model pellet? What is the purpose of flash 3? Okay, thank you, Mr. Lokesh. So if you have a components mixture which exhibit VLLE, or in other case it can also be heterogeneous azeotrope, huh? Then it forms VLLE, right? So in that case, if you want to separate these three phases, then you can use flash 3 pellet. Okay, for that. Okay, fine. So then just proceed further. So just put just to answer that question, we have seven kinds of reactor, and two of them are based on equilibrium. Sorry, two of them are based on stoichiometry, and other two are equilibrium, and three are, this is CSTR, like flow and batch reactor, which are based on kinetics. Okay. Then I think I already answered this question. Let us skip it. So the question is, the reactor block, which is based on stoichiometry, can run either simultaneously or sequentially. What do you say? Is it true or false? What do you think the answer? True. Okay, let me see how many of have responded. Okay, thank you. I have three responses. So that means, I'm thinking, and as I can assume that you are able to follow the lectures. So in one of the lecture, professor was telling it can either be used simultaneously or sequentially, right? Right. So what is the simultaneously and sequentially? How do you explain this? Can anyone tell what is the simultaneous solving and sequential solving? Will it affect my final solution? Explain simultaneously and explain sequentially, both individual, and then how do they compare? Can anyone just respond for this? Anyone? What is this solving simultaneously and solving sequentially? Will it affect my answer? No one? Acha, you don't, okay, just answer this question in general. How does Aspen solves the equations or the model pellets? Leave about this particular question. How does Aspen solve your simulation, your flow sheet? I'm asking completely different question. How does Aspen solve your simulation? Whatever you gave, yeah, whatever you have asked it to solve. Just unmute and talk here. Difficult to type. Yeah. Someone texted. What is it? It assumes a continuous flow. Lokesh, can you just unmute and talk if possible? If you are in a good environment. What do you mean by sequential oriented, Mr. Nirmal? Oh, Nirmal says he's traveling. Okay, fine. Okay. See, Aspen Plus. Okay, fine, Lokesh. Lokesh, no issues. Thanks for your response. At least you are responding. I'm happy for that. Uh, See, Aspen solves sequentially. Okay, what is sequentially means? Let's say if I have three unit operations A, B, and C. This is for the people who don't know what do you mean by sequentially. Okay, so if I have a constraint that without solving A, I can't solve B, and without solving B, I can't solve C. Okay, they are connected in series. Okay, then it's called sequential oriented solving. Okay, which means A, B, C will be solved sequentially. First, the block A will be solved, and then block B, and then block C. If you want to solve C initially, that's not possible because you need to know outputs of B, which will become inputs of C. Okay, so this is called solving a flow sheet sequentially. What is equation oriented? Putting all equations of A, B, C together and solving it once. Okay, so in either case, your number of equations and the number of unknowns will still be the same. Your number of degrees of freedom will be zero. If you don't have degrees of freedom to be zero, then you won't be able to solve any equations because you won't have a unique solution. Either you'll have zero solutions or you'll have infinite number of solutions. Okay, so if you are trying for a unique solution, then you need to have degree of freedom to be zero. So in this case, solving it sequentially or based on the equation oriented, you'll still have the same answer. Okay. So the basic difference is solving one unit operation after another is called sequential oriented approach, and putting all the equations related to blocks, all modules available in your simulation, and then solving all of them together is called equation oriented. Okay, so that's the basic difference. Okay, anyways, so I'm just proceeding further in the interest of time. So which of the following modules are the pressure changes which are available in Aspen? In anyone respond to this? Pump, R comper, M comper, and M pump. Which of these are available in Aspen for simulating your pressure changes? Such as if you want to increase the pressure of a stream or decrease the pressure of a stream. Okay, okay, who is that? Okay, so okay, you are telling pump is available. Okay, do you find any other model pellet which is available in this, or it's the only pump? ठीक है, कंप्रेसर में यहाँ पे दो नाम पे दिया गया है ना, so which one do you think is the one? Yeah, thanks for the response. It's pump and multi-stage compressor. So, can someone explain what is difference between pump and compressor, and where do we use pump and compressors? What is the difference between a pump and a compressor? Both are for pressure changing systems, right? So, where do we use this? In, let's say if I have a system, I don't know which one between these. Okay. Okay. So, why is there a such separation between liquids and gases? What could be the reason? See, for the people who don't know the difference, so pump, what she's telling is pump is used for yeah, I mean, someone has responded properly, technically correct. So pump is used for the liquids, okay, which are incompressible fluid, with incompressible fluids, okay, and compressor is used for gases, okay, which can be compressed, okay. So what happens if we send liquid through compressor? What do you think it will happen? What happens if we send liquid through compressor? So in your I mean in your just friends discussion, you might have a thought, right? What happens if we put petrol in diesel based engine and diesel in petrol based engine? Have you ever discussed this question? So you might have discussed, at least we have discussed. So analogously, uh, what happens if I put liquid in compressor and gas in pump? Anyone? What happens if pump cavitation? Okay, nice response. Compressor not move. Not move can be in, I mean, you can just put it in better terms. Not move, what do you mean by not move? Compressor plates will damage. Okay, yeah, you're correct. In our lab, we unexpectedly we send a liquid through compressor. Okay, and the compressor died immediately because the volume occupied by uh, normally compressors we had to lose a rotary vane compressor which is based on just a rotating one, okay, so it decreases volume upon rotation. So once the liquid entered the compression space in the cell and the shell side, what happened was it was unable to compress the liquid because basically the liquid is incompressible, right? And suddenly the compressor died, stopped working, and after that we had to just dispose that compressor. So you can never send a liquid steam into a compressor. Compressor will immediately die because the purpose and the design is completely for the gas part, okay. And pump, yes, as I mentioned, it's the cavitation issue. So in either case you can't send vapor to a pump and liquid to the compressor, okay. So it's the design itself is completely different. Okay, anyways, in this case the answer is the pump and the multi-stage compressors, okay, available both the pressure changes are available in Aspen for simulation, okay. And then if let's say if your discharge pressure is 20 bar as shown in this figure, okay, can you tell what is the inlet pressure of this system? This is an input to the pump, okay. The inputs are given, which says the discharge pressure is 20 and asking the inlet pressure. See this question, for this question you can refer this figure, okay. What is the inlet pressure of the system? Can you answer question 5, please? See, this is input to the pump, right? See, it says pump. And your discharge pressure means it's your output pressure. Okay, discharge pressure means it's the output pressure of the pump. Okay, so given output pressure is 20 bar, you're asked to find out what is the inlet pressure using the data available in this. Can you just read the question again and respond? The people who have responded. Yeah. See, in this particular case, we gave input as pressure ratio. Do you see this? Pressure ratio, a value to be 4, right? So what is pressure ratio? It's the output pressure by input pressure. Okay. It's the ratio of output pressure P2 P out by P in. Okay. So given the discharge pressure is 20 bar and the pressure ratio is 4, so my inlet pressure will be 20 by 4, right? Right? Yeah. Thanks. So in this case, since the pressure ratio is given to be 4 bar and the discharge pressure to be 20 bar, your input pressure will be 5 bar. Okay. Yeah. I'll just skip this question. This is seem to be a trivial question. Okay, so I have question 7. A turbine converts kinetic energy to electric energy. Is it true or false? Acha, before this, what is turbine? What is a turbine? Sorry, I couldn't hear you. Can you just repeat it? अच्छा, तो टरबाइन का इनपुट क्या रहता है? टरबाइन का आउटपुट आप बोल रहे हैं इलेक्ट्रिसिटी रहता है. So, okay, okay, fine. So, what is difference between a turbine and a compressor? For everyone, what is the difference between turbine and a compressor? Okay, okay, and turbine? Okay, okay. Can you analogously put I mean, just give a common statement between compressor and a turbine? I'll just make a small statement with respect to compressor and turbine. Let me know if you feel it's a proper definition. I would say a compressor converts electrical energy to mechanical energy, and it's the other way around for turbine. Is it a proper statement? Compressor converts electrical energy to mechanical energy, and turbine it's the other way around. So it converts mechanical energy to electrical energy, right? So just remember these 2 points, okay? So if someone asks you, if you have to put it technically, you should tell mechanical energy to sorry, electrical energy, okay? Okay, fine. So this is trivial question. Let me just skip. Yes, there's one more thing. For this question, you need to open your Aspen. Okay. So I want to know the Peng-Robinson equation of state with the Boston modification property method is represented by something in Aspen Plus. The people whoever have Aspen with you now, can you just check it? What does it say in Aspen? Okay, thanks for the response. Others? Okay. See, you know Peng-Robinson equation of state, right? You must have used in Aspen. So, this Peng-Robinson equation of state, along with the Booston modifications, is a property method available in Aspen. Okay. So, for every equation of state, there is a particular terminology which is given in Aspen. Okay. So, what terminology is given for this Peng-Robinson with the Booston modification? You don't have to remember this. You don't have to remember this. Just go to your Aspen, see in the property method by what name it's given. So, this way I'll have a confirmation that you are able to change the property methods. That's the agenda of this question. Okay, I don't expect you to remember this. Okay, thank you. So when you go to the property method section specification, if you want to just change any property name, method name, you'll be able to see, in this drop down box. Okay, so there you'll be able to find the statement which says this. Okay, thanks for the response. You want Mr. Rajit says question number 9. So you see, it was a bit trivial question, so that's why I skipped. Okay, but anyways, if you want to just respond to this question in that case. So yield block doesn't need kinetic or sizing information. Is it true or false? Okay, thank you. Others? Okay, people posted some. Okay. See, in one of the lecture slides, professor actually was explaining this. So it doesn't require any kinetic or sizing information. Okay, it's an estimate. It's not the exact prediction of the system. It's just an estimate. However, it's based on some assumptions. That's all. Okay, uh, fine. So stoichiometry block is used where reaction kinetics are known, but stoichiometry is unknown. Is it true or false? True. Okay, others? Just read the question again. Others, hardly three or four are responding. Can see Nirmal, Lokesh, Nikita, Ajit. However, there are 11 candidates today. See, Ere, do respond or let me know in case if I have difficulty. Yeah, that's the whole idea of this interactive sessions, right? If I keep on talking, it doesn't make sense, right? Yes, it's false, right? Because the name itself says it's based on our stoichiometry. So if you are claiming your stoichiometric is unknown and kinetic is known, how will you use a stoichiometric block, right? So can you tell me which kind of reactor will you use if your kinetics are known? If you know reaction kinetics, which block will you use? Any responses? Okay, thanks for the response, Srila Raju. Others? Is CSP? Okay, okay, thank you. Yes, you're correct. So all three of them can be used in this case if you know the reaction kinetics. Okay, good. Thanks for the response. So yeah, how many reactor modules are available in Aspen? This is kind of a trivial question. I don't think I have to spend the time. Let it be. Just can you answer this quickly? Yeah, it's seven, right? I mean, there's no point in explaining this. You have seven pellets. So there's a format called IAPWS. What does it stand for? You don't have to remember this. If you have Aspen in front of you, go to property method, check for IAPWS, and tell me the full form of it. Okay. Others, were you able to see? Are you able to locate? Okay, three if you have responded, four I guess. Yeah, Chit has also responded. Why do we have a separate property estimation for water and steam? So I would say I'll have one equation of state or one equation which can represent properties for the entire, I mean, all the components which are available. Is it possible such? Or why do I need to have a specific equation of states for few components? Let's say if I have hydrocarbons, I was told to use Peng Robinson, so I'll use that. For water, I'm told to use IAPWS, I'll use this. So is why there is a constraint that we need to use these particular equations for property calculation? Can't I use Peng Robinson for water and steam, or the other way around? What do you think? So I'm telling, can't I have a generalized equation? Is it possible to have such? Or okay, let me. This is secondary question. The primary question is, what happens if I use Peng Robinson for calculation of properties for water and steam? Achieves higher degree of accuracy based on properties, application for industries. Okay, yeah. Okay, one way of putting answer is correct. Yes. Thanks, Mr. Ajit. You're halfway through. You're almost there, in fact, not even halfway. Others, what do you think? See, whatever equations, properties you are using, they're just prediction of the actual behavior of the system. Okay, it's just a prediction. It can always be way off from whatever the system exhibits in reality. Okay, so in this case, uh, considering, let's say, if you take example of hydrocarbons, the predictions which we get from Peng Robinson are kind of closer to the actual system performance than this IAA, PWS, whatever we have seen. Okay, so essentially every model is just a prediction. It will be slightly off from the system's actual behavior. However, the closer your model to, closer your prediction to the actual data is better the equation, which can be used for property estimation for other temperature ranges or kind of extrapolation essentially, right? Or extrapolation or interpolation, whatever is your application. So, having different equations for different categories of components, uh, it is observed that you'll have a better prediction of properties. Thus, you have different kinds of equations. Okay, so you have thousands of equations which can be used for various components. Okay, so yes, you can't count it by fingers. You have thousands equation of states which are there these days. And now you have Helmholtz equation of state. Okay, so which is kind of based on, I mean, the recent one. So I will discuss more later, okay, about this Helmholtz and all. Fine. So it's a chip response saying like it's a gas, we can use water then water. Okay, it is special correlation with steam table curve upon regression. See, every model is based on the regression and fit. Okay, for whatever experimental data available, every model is fitted over a certain range. So a model is just a prediction of the system. It can't be 100% accurate anytime. Okay. So that explains this. Why do we need a different equation of states for different things? Okay, so that's what I had planned for today's lecture because I'm not even an institute. I kind of don't have a license for Aspen also. That's the reason I couldn't give any hands-on problem today. So if you have any questions that I can answer orally without use of Aspen, I'll be happy to take. Yes, you have some question? हाँ, बोलिए, ठीक है। आउटपुट दिख के नहीं रहा तो आप सारे इनपुट सही दिए क्या? हाँ, माने वो ये बोल रहा था कि शायद एनआरटीएल सही मेथड नहीं है या कुछ आप गलत इनपुट दे रहे हैं। ये कुछ बोल रहा था शायद। Actually, thing is I didn't look at your assignment, so I'm unable to figure out what exactly you're asking. But it essentially says that whatever model you have used for the given components may not have a better prediction. So you have something else inbuilt in Aspen which can have a better prediction. That's what it says. Uh, एक बार आप एक काम कीजिए, आप एस्पेन प्लस से नया फाइल ओपन करके उसमें एक बार करके देखिए, शायद इफ माय गेस इज करेक्ट यू मेड सम माइनर mistake while giving input in Aspen Plus. Just open a new file, start it from the first. Let's दिखाइए, but no issue is I can't do anything right now. I don't have this license. Okay, let me stop presenting. You can share it. Just share your screen. Let me see other questions meanwhile. Sir, I have difficulty in understanding question. थोड़ा ज़ूम कीजिए ना भाई। हाँ, ये अभी दिख रहा है। Warning in physical property estimate that your binary parameters for all the components are zero. Okay, so it essentially says that your binary interaction parameters are zero. So what you can do is use unifac model for predicting binary interaction parameters. Yes, that will help you. ये बोल रहा है कि see normally in any modeling and all ना you have only binary systems which are modeled together. Okay, uh, for n number of components, all the possible combinations of binary systems are taken, and then finally the properties are estimated. Okay, so in this case, it is telling your binary interaction parameters is which are default available in Aspen are zero. Okay, so to have a better prediction, you need to have some value for binary interaction parameters. Okay, since you don't have experimental data for the given components, you can use Unifac for predicting the binary interaction parameters first, and then use NRTL for getting the property estimation. So you can just go to the property methods, and then there is sub column called binary. I don't remember exactly. लेक्चर पढ़े हैं ना हाँ हाँ ठीक है so correct. Correct, correct. Just click on that. This should solve your problem. That's all is your issue. That's yeah. You can. अच्छा अच्छा ठीक वही करना था. Okay, okay. Fine. Now it's clear, right? Can you just stop sharing your thing? Okay. Thank you. Okay. Please provide the video of solutions of assignment. How to solve that? We are facing some issues regarding assignments. Okay, I can do that. First, and can you explain why Unifac is used for binary interaction? Since you don't know the binary interaction parameter, you use Unifac for predicting binary interaction parameters first, and then you'll try to predict the properties. Okay, that's the reason. After downloading Aspen from my, I'm facing license error. Okay, so with respect to installation and license thing, it's out of my jurisdiction. Just write a mail to the person mail ID given in the website. Okay. How do we find out what all other properties will affect if we change model of estimation? Some properties like solid pure. How do we find out which all other properties will be affected if we change property? See, you're just simulating, right? You're not spending any additional money. Just try changing different properties and see how way off your predicted properties are. I can tell you your predicted properties will be way off by 200 or 300%. No, see, I'll tell you one thing. I'm not supposed to discuss anything related to assignment before submission. That's the point which is told to me. Okay, so I'll be able to detailedly discuss only the coming week, the whatever this week submission you have. So I can't do that at this point of time. Okay, yeah, do one thing. Can someone just share your assignment because I haven't gone through your assignment. Whoever have your assignment as of now can just share it. If the installation is done currently, open it while on internet connection. Can you share it via laptop? I mean, I can't see your screen. Someone is trying. Or on the phone itself, just open it and share it. Yeah, yeah. Thank you. See, you are showing your answers to everyone. Okay. Open new simulation in Aspen with electrolysis with metric. Add the components H2S and NH2S. Change the model for estimation of liquid pure components to and run the simulation and answer the following. What is the default model for paper? See, this one you should be able to access in the model sorry, property methods. Okay, so I the path I don't remember exactly where do we go, but you should be able to change it in property methods itself. There won't be any other tab for this changing the liquid pure components to VLVT. That's the only place where you can change things. Okay, just try it once. Okay, I'll try putting a video by tonight. I mean, could have discussed. Just try it once. I'll put a video by tonight. Okay, at least for this. Any other questions do you have? Okay. Okay. Can you just share the previous assignment thing on your screen? Yes, which I can say this. Okay. Vapor phase cracking. First order reaction with respect to acetone, activation energy is given. Chemical filter base method is given. So you're asked to estimate binary interaction parameters using Unified, right? Uh, Consisting of pure heat is passed through a heater. It is attained a temperature of so and so with no pressure drop. Okay. So is this the same issue with others as well, or you are in proper range of answers whatever mentioned? Others, can you just respond? Do you have similar issue? Yes, Mr. Rajat, you raise your hand. What is it? Just unmute and talk. You got it right. Okay. 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 You couldn't get. Okay. Let me just take a screenshot of this. Okay. Okay. So I'll try solving this question. Okay. Whenever I have license to Aspen, then I'll post it in that folder itself. Okay. If both of you have individually tried and got the same answer, then there might be some issue. Okay. I'll just check it and let you know. Yeah. Yeah. What is your So that's what I'm telling. If individually you tried it out and both of you end up getting same answer, that means that there might be some issue with the question itself. So it's possible, right? So let me just check it again. Okay. 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 Fine. Let me try it out. Yeah. Without solving this, how can I just respond, right? So just think from my point of view. Also. Okay. What is what was the error? It's going into not responding more. So I mean, so probably your system. I mean, what is your RAM size? Okay, probably your processor is RAM. Yeah, 4 GB is too small for that. Probably that's the reason. When you just on the ASP, then it takes about 2 GB. So
system will require about 2 GB to operate. So probably I think it's the RAM issue which is creating problem. No, it's not with the software. For example, I'll tell you in my system, this is a 32 GB RAM system, whatever I'm using. For me itself, it will take some time to get the Aspen settled. Okay, so it's not issue with the software, it's issue with. Okay. Any other questions do you have? See, next week also I'll be out of the institute. Okay, so I'm on leave because of my personal reasons. So that's the reason I was unable to. No, I couldn't put any Aspen related questions in this week presentation. I'll try getting license for the next week and try to give some hands-on plus exercises. And parallelly, I'll try answering the questions which were posted today, assignment, previous assignment related questions, and hopefully by tonight I'll have a video uploaded in the folder which I shared in the website. Okay. So in case if you don't have any questions, shall we close today's session and come back next week? Okay. Then okay then thank you and see you next week. Have a good week. Thank you.